Today we're going to do a brain dissection, and the wind's a little crazy outside, but I really don't want to make my house stink. So I have here this brain. It's a sheep brain. Okay, it's a particularly small one. I'm thinking it's more of a lamb, right? So the cool thing about, well, not the cool thing, but these are left over from harvest, well, from the meat industry, and so these aren't like, they don't just kill the sheep for their parts. They use the parts that they wouldn't use in the meat trade for biology. Okay, so this is in the perfect solution, which means I can dispose of it, and it's supposed to be the Dura Mater intact, which is the outside layer. Yeah, so we're gonna look at this and see all the different parts, hopefully. I'm gonna wear gloves. And this is the worst part about distance learning, is you guys can't do this, because it's really cool, but I can't send it home. I considered it, especially with the eyes, but because I have enough eyes for everybody. But we'll do the eyes like this too. Let's see if I can't tell what you guys can see because it's really glary out here. But so it's in its little sac right now, which is the Dura Mater, and which is part of the meninges, the stuff that gets inflamed during meningitis, right? And you're gonna see that it's pretty durable when I take it off. There's a little bit of bone here, which always kind of grosses me out a little bit. Other things you can see, and I don't know if you can see or not, but these are the optic nerves. Can you see that? So they're pretty big, even on this little sheep. Yeah. And this is the brainstem. So you got to imagine that, you know, a sheep is laid out a little bit differently than us, right? Their head is, you know, instead of their brain being shaped so the brain's up here and goes down, it just goes straight back. So it's like that. All right, so we're going to start by removing the Dura Mater, or the meninges. And I haven't ordered one like this from them. It's a lot like the thickness of paper, similar to wax paper. And lots of times things are just easier to do with your fingers than with your tools. And just pipe up if you have any questions or anything. I'll try to, I can't tell if you guys can see well or not, so I'm sure right now it just looks like not much at all, but I'm gonna wind up losing these nerves. But all right, so I took it out of the Dura Mater, right? And so you can see that it's kind of translucent, right? But it is very durable. You see how hard I'm pulling on that? Right? And so that's where it gets its name Dura matter because it's very solid, hard, very tough. Okay, it actually means tough mother, Dura Mater. And like I said, it looks a lot like wax paper, but it's stronger than that. Very strong. Okay, and so that's part of the protection of your brain. Okay, and this brain is a little smoother than what I usually get. I don't know if that's because it's a young lamb or whatnot, but alright, so here is the cerebrum, right? This is the cerebellum, and this is the brainstem. So this part down here would be the medulla oblongata. Right? You flip it over. This is where the pons in the midbrain and hindbrain would be, in that area. Okay. I can snip here a little bit. And so when ours, you know, would be more like this, tilted that way. Yeah. All right, so one thing is, I think I remember telling you that, you know, with the eye you can see all the anatomy and identify it really easily. In this, it's much more difficult. Like, there's not a distinguished line between the frontal lobe and the parietal lobe and the occipital lobe and the temporal lobe. You can just kind of say, okay, the frontal lobe is in this general area, occipital lobe is in this general area, and parietal lobe, and then the temporal lobe, right? Remember, the frontal lobe is for thinking, parietal lobe is for sensory information, occipital lobe is for seeing, and the temporal lobe is mostly auditory. Okay. You guys see?
Mm-hmm.
Does it look kind of cool? So it feels a little like a squishy ball, right? Maybe like the firmness of a tennis ball. It's really similar to a mushroom, if you like mushrooms, or if you have touched mushrooms in squishiness, at least. Okay. So one thing that's kind of cool about the brain is that it is really easy to dissect, because you can just cut right through it with the scalpel. So I'm going to separate it into its two hemispheres. And there's the brain, right? Okay. So in the pictures you drew and whatnot, everything was way more obvious once again, right? So there are a few pieces that are pretty obvious, like this is the cerebellum, and you can see the arbor vitae, or the tree of life, just the white matter in the cerebellum, right? But up here is really not distinct, and this is less distinct than normal, and I'm not sure why. But you can see the corpus callosum, okay? And then the thalamus would be right in this area, right? And then the epithalamus, usually you can see the epithalamus, maybe. On this one I can't, it should be right in this area, and then the hypothalamus back here, okay? And that controls your hormones. Sometimes the pituitary is on there, but I don't see it on this brain. Yeah. No. So you can see it's really the complexity is not in the complexity of the like structures. It's more in the complexity of the neurons that are going in there, and so you can't really see how complex the brain is in comparison to the eye. Okay, so this would be the cerebrum, and then corpus callosum, thalamus, hypothalamus. But it's really not super defined at all. Okay. One cool cut usually, oh, looks like crap on this one, is a side view where you can see the gray matter and the white matter, right? But you really can't here. Let me try another one. Huh. That's weird. Maybe I'll have to do another one and see if it comes out. Yeah, you can't really see it. Usually you can. And white matter is myelinated and axons, and the gray matter is mostly dendrites, I think. If you remember from the stuff we talked about. But that's, you know, that's the brain dissection. And so if we were doing that in person, right, you'd stop and you'd draw each of those different cuts. You draw it first when you've got it out of the bag, and then you take the Dura Mater off and you draw it from an angle and label what you could. And then you slice it in half like I did and draw that and label what you could. But lots of times you're just kind of guessing, right? And so it just shows you, you know, that the complexity that you can see in the anatomy book is not the same complexity that you can see in real life. And that would go the same way if, and I might do a frog for you, the muscles are really hard to distinguish even though they're really well outlined in the book. Is there anything you guys want me to do to it? No? Like, just, you know, so I was using a scalpel before, but here's just a blunt probe, and you can just push it in, right through it. So it's soft like you would imagine. And, I mean, I've never eaten a brain, but it seems like it would be good. But I don't know. It seems like it would taste good, but you might get mad cow disease or something. So, I don't know.
It doesn't look like it would have much of a flavor.
I don't know. It looks kind of like fatty. Obviously, this one would taste like chemicals, but it's, I don't know.
It looks like tofu.
A little bit. Yeah. In some places, they have like chilled monkey brains for like ice cream, which, I mean, I kind of imagine it tasting that like fatty but not sweet. A little like a mushroom just because of the texture, but I have no idea. I think the meat eater ate them once, but even he's a little sketchy on it. Let me see if you can try to get the arbor vitae. See, there we go. Can you see the little tree?
Yeah.
Yeah. Can you see the little tree? Yeah. That's about the only place you can see the white matter in this one, which is kind of weird. And once again, this Dura Mater is really durable, and everything else, yeah. You guys have any questions? I know I already asked that, but